Hi, I'm Brandon, and this is my Lab 1 tape experiment. The purpose of this experiment was to create a charged piece of Scotch tape and to calculate the excess charge created. To create the charged Scotch tape, I placed a base tape onto a table and made a U-tape with a handle to place on top of the base tape and rip off, creating a charged piece of tape. I then hung that charged piece of tape off a table and had it interact with various objects, such as my hand and a pen. Figure 4 shows the last part of the experiment, where I used two pieces of Scotch tape that were similarly charged and had one repel the other in order for the other to float. I ended up observing that the tape is positively charged because it is attracted to the negatively charged pen that I created through rubbing it on a sweater. My first order of business was to calculate the gravitational force of the tape, which ended up being 1.96 times 10 to the negative third. I used the length of the tape, which was 20 centimeters, and the weight given in the experiment, which was 1 gram per centimeter. Since I assumed that the entire charge of the tape was located at a single point to get a rough estimate of the charge, I can also say that the force of gravity equals the force of the electric field at the float distance. I found the distance between the tapes when one began floating, which turned out to be around 0.25 centimeters. Using these two numbers, I was able to calculate the charge of the tape, which was 1.167 times 10 to the negative ninth. Dividing that by a single charge of an electron, I found the total electrons transferred to one piece of tape to be 7.25 times 10 to the ninth electrons. Then I found the total electrons on the surface of the tape, knowing the approximate length scale of an atom as 1 times 10 to the negative 10th, and my tape dimensions as 1.778 centimeters times 20 centimeters. I calculated the surface area and divided by the approximate length scale, and found that to be 3.56 e to the 17th atoms on the surface. I divided the electrons I calculated by the total electrons on the surface to find the ratio of atoms that gave up their electrons. It turned out for every atom, 2.04 times 10 to the negative 8th electrons were given up. Overall, this lab became a beautiful representation of real-life observations of electrical fields and allowed me to calculate excess charge on a piece of tape within an order of magnitude, with pretty simple measurements. Questions. What if electrons had a positive charge and protons had a negative charge? This would basically not change anything in my experiment, except for my tape would be negatively charged instead of positively charged. But assuming the universal change, everything would also change, and the pen would end up being positive while my tape is negative, and they would still attract each other. Why is it important to handle the charged tapes as little as possible? Because when the tape comes in contact with, let's say, my hand or another surface, then the charge will move from the tape to my hand or the other surface, and then the tape will no longer be charged, and the experiment won't work. This is a link to my code, which I will show. Basically, I typed in initial conditions, made my two pieces of tape, found the calculations for the force of gravity and the force of the charges for the electric field, and then it ended up looking like this, where the electric charge is 3.6 times e to the negative 9, and the magnitude of the gravitational force is negative 0.01962. The electrical charge is slightly different from my calculated one because my force was a rounded version of the negative 0.0196, and they used the whole number in the program. So yeah, that is the end of my lab report. I hope you enjoyed it.